There are two things I really love, and that's things that go really fast, and lots of numbers about things that go really fast. So when it comes to monitoring Lustre, it sort of works out quite well. So we can figure out how to work in the machine. Alright, so that's just a rough overview of the few topics I'll be talking about today. Just bother to put this up. So current state of monitoring, or watching the watches. So a lot of monitoring solutions are pretty much rigged up to do one or two things. You've got things like your Nagios and EDIA and stuff like that. They're generally more about telling you when something's broken. They're less about performance metricing and that sort of stuff. They usually have a lot of the logic on the clients, which when you're trying to squeeze every last little megabyte of bandwidth and load out of your OSSs is probably not where you want to be doing hundreds of forks of execs, especially not when you're under a heavy load or something. Some of the graphic can be inflexible or not as an actual part of the package. What is it? Nagios, for example, it's primarily a binary agent, so it's, if you want to add things to it, you've got to add on scripting or compile it from scratch. And you usually need more than one sort of thing. So, for example, adding the graph add-on or the mapping add-on to Nagios or something like that to get a little bit more visualization about what things look like now. Data reusability is low. In that, you've got your triggers on one data point, but that's it. You can't aggregate those without writing more scripting that aggregates them and then puts the results in and that sort of thing. Not visual agents, so you're doing a lot of the coding yourself to monitor things, especially things like Lustre and stuff, where they're not really the usual goal of a lot of those products. They're more about just telling you that your VM's died. APIs are a bit lax in some of them. And yeah, as I said, combinational tests are not possible, so that goes to data reusability. As I said before, when you've got a heavy load, some of the clients, they're very big clients. You've got things that are looking for to be moved. Sometimes they can be the first thing that gets targeted or the first thing that sort of stops responding when there's very heavy memory pressure. Segregation and criticality is interesting because there will be things that you want to monitor, but you don't really care if you can't monitor them when things are going wrong. Like, you really probably don't care about how much free space there is on route when you've currently got a couple 100,000 IOPS streaming out the InfiniBand. So merging data for internal and external, some of them you have to have all the data from the object coming from the object. You can't sort of have side channels that allow you to then insert that data as part of that object that you're monitoring from elsewhere, and integrating into and automating workflows. So setting off triggers like if your var log is full and you've decided you wanted to automatically clear that out or do something when that happens. Not a lot of them support that as well. So what I decided to do, build my own white sheet. So obviously we went into a few ideas. We didn't want to reinvent the wheel, so there's a lot of good work by good people out there already. But we wanted to monitor everything because sometimes when you've got some pretty weird things happening, they're happening because you've got more than one thing happening at the same time. And if you're missing one bit of data, you can't sort of see that all of these things are connected by some common thread. Being able to take actions when things happen, so whether that's just notifying something or doing something automatically was important. Looks at performance, like I was saying, with your base sort of Nagios installations, they generally just go, this is broken. Sometimes they have the performance data, sometimes they don't. It depends on how you've implemented it, but it's not sort of one derived. You're sending a fail or a pass instead of sending a bit of data and letting the server evaluate it and decide. Ease of access was big importance because if you've got heaps of data but you can't access it, it's not very useful. The more accessible it is, the more you can manipulate it and the more you can turn that data into usable information. Obviously the rest of them speak for themselves. That bottom one there, moving the logic, again, that's all about wanting to know what's going on when things are going very badly. And if you've got very complex logic on your OSSs, for example, and you've got somebody absolutely pummeling them, you don't have 200 to 300 fork execs happening while you're trying to service that load because one of the two isn't going to happen, at least not when you want it to. So again, the separate monitoring of different criticalities, and so this is trying to figure out how to monitor the stuff you want to have monitored when things are going wrong, monitored in the lightest way possible to give them the best chance of getting out while everything's going wrong. Being able to use a 10-foot view, so something you can put up on a screen and just look at it and go, everything's green, that's fantastic. And then just being able to then split those views out so you can give one view to somebody who focuses on one area and a different view to somebody who doesn't need to see various other bits. And then obviously making it so that it's not set in stone. So, what colour is my light shade? So in the end I picked Zabbix. I don't know if any of you have played with Zabbix before. Zabbix is basically built around the idea that you put a bunch of data in and then you do all sorts of things with the data on the Zabbix server. So you're trying to keep the client side as light as possible and then manipulate it there. We've got some fully automated sort of setup, so when our nodes roll out, they just sort of spring out of the box and then they contact the Zabbix server they're supposed to be watching. I've built some Python modules and I built it modularly so that way again, when they figure out what they're supposed to be doing, they only load the bits that they need and there's no extra baggage floating around. And then the plugins are all designed so that you can use them without the rest of the architecture. If you just want to find out a certain value, you just run the plugin as a standalone and it spits it out, standard out, so that you can do whatever it is you're trying to do. So the monitoring plugins we've put together are to monitor all the different things that we have. So we've obviously got the NetApp-based IS4600s, IS5000s, IS5600i style NetApp arrays. And then we've got the 7500, which is the DDA 12K 40s, I think. Is that right? Yes, good. And then obviously on the Lustre. So we've got the server-side performance metrics we pull out, but we can also pull a lot of details about what the clients are up to from the server side, which then means you don't have to monitor it from the cluster side, and the cluster can get back to doing cluster things. So on the storage arrays, we keep track of pretty much everything, so we can tell when any single one of those arrays is having a bad day, which obviously then we can look at the rest of the data and correlate, oh look, things are slow, okay, trial failed. We've got inventory of them, so that way we can keep track of which disks were in there and that sort of thing, which can be very, very helpful when you're trying to figure out if that's the new one or have we got a bad batch with similar serial numbers and that sort of thing. You can, as I said, you can configure how long the history is. Big one is the read-write latencies. That's really important. We can pick that up in all in one spot. That's really good for finding slow disks if the platform doesn't do it by itself. And the other one we can do is drive-side bandwidth because it's nice to know, again, finding slow disks. Stuff we do on Lustre. So we collect a lot of data out of Lustre. All the basic NDS operations, because that is actually one of the most important ones to keep an eye on. Your bandwidth, because who doesn't want to know how fast things are going. And we monitor that at multiple levels, so we can see that from the OSS, we can see that from the OST, we can see that through the on-the routers. And then obviously being able to break out that bandwidth and have a look at how big all the different packets are, whether we're getting 1 megabytes, whether some business decided that 4K is the place to be. Whatever it happens to be, we can actually see that in near real time, which allows us to do job profiling and stuff like that. And then obviously per client stuff as well. So when we do see something weird happening in the metadata server, for example, we can then go and find, oh, it's that guy, and we can look at his job and say, yeah, let's not do that. Then obviously just all your sort of standard stuff, so you can see CPU load and all that sort of stuff, which is pretty powerful, of course. We've also got a couple that watch the multi-path XDM, depending on what platform it's running on, and then the pacemaker, so that way you can keep an eye on failovers and that sort of stuff as well. Okay, so the important part, looking at performance, well, as I said, where did all my IOPS go? So, how much performance do we have? Because, there's no point in saying, where's my performance gone when you don't actually know what you've got. And obviously you've got different performance values that are important that help you get a better picture of where your performance is going, where you're losing performance. So for example, this one was an uncontested IOR run. I believe it was on GData 3. Looks like it, doesn't it? And as you can see there, you've got your two different things, and you can, straight away, just looking at that data, you can see things that you wouldn't be able to tell just from the output of IOR. You can see that there was still some writes going on as the reads were ramping up. You can see, where your plateaus were. In a different one that I'll show you in a few minutes, you can also see interesting things with different arrays and where the caches are loading up and that sort of thing. So that's a good one there for figuring out how much do I actually have. This is another one. So this one's for looking at your MDS, because obviously if your MDS is underperforming, nobody can really do anything. So you can't find your files, and it's pretty pointless. This particular one is just the sort of average use on a pretty boring kind of day. And it's broken out into the various different types of metadata operations you have, and they're all on the graph there, so you can at a glance see what the clients are up to and start to figure out what's going on. This one here is LNET routers. Again, this was a pretty average kind of day. And this is just showing you, so there's two different views there, and they're both useful for different things. So that one there is a stacked, and so that gives you a good idea of aggregate, whereas the other one over here is an unstacked. And the unstacked is actually really useful when you've got things that are performing slowly, because obviously you'll have these outlier lines. And when you've got your outlier lines, you can start to investigate those particular LNET routers in this case to figure out why that one's lower than higher than the rest, and then start to work towards fixing that or making the rest look like the one that's performing better. Again, it's all about getting all the information that lies into your hands so you can start to make more informed choices about what your file system's doing. This one here is actually a really interesting one. This one's actually the raw block writes and reads that go out to the file system as they are seen coming into Lustre. So if you look on the read side there, that one, there's 2,000 seconds worth of 4K and 2,500 worth of 1 meg. So, you know, that's a sort of a standard day. But on a bad day, you might things might be performing not so well, and you look at your bandwidth, and your bandwidth is pretty low, and you're like, well, what's going on? You have a look at this sort of graphing, and you can go, oh, look, it's all 4K IO, that's why my bandwidth's so low, and I've got nothing left. It's really also good when you have new workloads run, because you can in real time see exactly what that workload is doing to your file system. That way you can provide better guidance to the people who've written a particular workload in how to adjust it and make it behave better, especially if they're doing lots of 4K or something horrible like that. The writes are pretty good usually, so that's always nice. So then, yeah, where did it go? So I've got some examples here of things that we were able to do because we had the metrics. This one here, there was a particular user who was running an interesting job that did a lot of finds, and they were running multiple finds on multiple nodes. As you can see there, there's 3.8 million get-atters a second in those big bursts there. At this point, somebody basically said, Lustre's feeling a bit slow. It's working, but it feels slow. And if you went and looked on any of the nodes, the MDS or the OSSs, they all had fairly low load and weren't particularly unhappy. But then when you went and had a look at the graph, you could see that somebody was absolutely smashing the MDS fairly consistently. And so that was causing it to feel slow. But for most of the other available or non-obvious metrics, the system looked fine, it looked healthy, it was online, and there was not a problem. So being able to get in real time see what the users are actually doing, you have a better idea of how to then diagnose it. In that particular case, we then went and used the client-side metrics to go, it's that particular client, that's when we found, or it was a group of clients, it's that job, and that's how we figured out what they were actually doing. Next one. This was another one. Again, it was a Lustre feels a bit slow, and this was on GNR1. It was literally sitting at like 99 thereabouts% read bandwidth consumed, which obviously is going to make things for other people run a little bit slow. This wasn't even migration or anything. This was just a user workload that was doing all the right things. So it wasn't anything really to do, but it was just nice to know that, yes, things are going to feel a little bit slower for some people because somebody is using literally everything. And being able to see that again in real time and say, you know, if there was the ramp up, there's the actual job running, it's using it all. Cool, that's what the problem is. Then being able to communicate that and then maybe find out if there was a way they could run it slightly smaller. This one here, so this actually happened just the other day. We were just working as per usual and things sort of stopped responding a bit. There was a few weird things. And you can see that big dip in metadata, everything basically dropped down to zero for a short period of time. A couple of the OSSs had failed over. The exact trigger looks like it was just some big RMs causing the chorus sync to panic for no reason. But you can see right there that yes, everything slowed right down, but then it all came right back up, and you can be fairly confident things are going again because the befores and afters look good, and then you can go back and diagnose the rest of it. But you've got that, up to the minute data about what's actually happening, are things looking normal, are we back to good, where do we go from here, sort of thing. So as I was saying earlier, profiling workloads. So this one was actually taken while Daniel was doing some of his data gathering for his presentation. And as you can see there, we've just got a large group of writes. So you can actually see when everything started and finished. And again, if you've got somebody who's running a new workload and they're a little bit worried about what their I/O looks like, or you're worried about what their I/O looks like, you can get them to run their particular job, and then you can look in real time and see exactly what it's doing, what impact it's having. For example, immediately after Daniel finished, somebody looks like they decided to fire up all the 4K I/O. So that might be somebody we need to find and have a chat with. But the idea there is, again, it's all about having up-to-date information that you can use to then make better choices about how you build your file systems, how you use your file systems, and more importantly, how your customers are using your file systems. Because ultimately, it's all well and good to build a giant speed demon, but if your design doesn't match their use cases, I mean, they're going to just say it's slow even when it isn't. Okay, yeah, so this is the one I was talking about, and there's some little peaks that you can see on the front of those ones there, and then it sort of levels out a bit. And so from what we've been able to tell, based on what the array was feeding back at the same time, is that basically that was the caches just flooding, and then once the caches flooded, everything was just going basically straight out to disk. And so the more data you get around that, the more you can sort of understand how the cache behavior plays into your peak bandwidths and stuff as well. I think it was just pretty interesting because you can actually see it very vividly on those graphs. Okay, so that's another one we've got. This one we have had interesting with this ones before. So this is coming off of the LNET routers. So this is showing you total RPCs in flight. And so sometimes you run into weird cases where somebody's sending a lot of very small RPCs, not necessarily just for get-atters and that sort of stuff. And it can flood the LNET routers. And again, everything looks normal because nothing's loaded up, there's no disks that are doing anything. You've just got a lot of RPC traffic and that's slowing everything down. Being able to see the RPCs allows you to do that as well. So, like I said, it's all about finding all of the metrics that are hidden away deep in Lustre and getting them into a way that you can actually see them, and then from there do things with them. So for example, that's actually an aggregated view, so that's all of the LNET routers, but we've actually got these views per LNET router. We've got them per pretty much every base item that they have in Lustre. Obviously, that was saying your 10-foot view, your general health status. We've got a couple of full OSTs, so they're up in the red there. That's why. So again, you walk in, first thing you do in the morning is you have a look, and you can see straight away what does everything look like. What do I need to look at first? Full OSTs being one of them. The other thing we've added recently was some metrics around our NFS boxes. So we've got a lot of the Lustre re-exported by our NFS. And there were people who were saying that it probably was not giving them the performance as such. We went and instrumented the NFS boxes so we could actually see how much bandwidth they were actually using versus how much was actually available, and start to work on an idea as to where this perception of lack of performance was coming from. Was it bandwidth, was it items, was it netted underperformance, what was actually going on there? So that way, again, it's all about getting the metrics so that you can break it down and build a better solution that targets exactly what